Right now, as you are watching this, seismographs on 6 separate continents are recording elevated ground motion at the same time. Last week, a magnitude 6.7 tore through Sulawesi, Indonesia at 2:37 in the morning, shaking apart concrete structures along a coastal city of more than 400,000 people. 2 days later, a magnitude 5.8 struck at only 12 kilometers below the seabed off Trinidad and Tobago, a shallow earthquake that sent 11 full seconds of violent shaking across 4 countries simultaneously. And in California, the San Andreas fault system released a swarm of 15 separate earthquakes in a single 72-hour window, the largest reaching magnitude 4.6, while USGS instruments detected concurrent elevated microseismicity stretching from the Parkfield segment down toward the Salton Sea. That is 3 separate events on 3 separate tectonic systems in less than 1 week, and those are just the headlined ones. Africa's East African Rift shifted on June 18th with a magnitude 5.1 beneath Lake Tanganyika. Japan registered a magnitude 6.170 kilometers offshore the Tohoku coast on June 21st. Turkey logged 12 aftershocks above magnitude 3.5 in a single week along the East Anatolian fault. The USGS Global Seismograph Network has recorded more than 200 significant seismic events across every corner of the planet in the past 14 days. This is not normal news cycle noise. Something significant is happening across Earth's tectonic systems simultaneously. Today, we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever personally experienced an earthquake, a real one that moved the ground beneath your feet? Tell me where you were and what it felt like. I read every single one. If you want to be the first to know every time something major happens, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm shows it to the people who need to see it. Now, let us get into it. Let us start in Indonesia, because what happened there is the clearest opening chapter of this story. On June 17th, 2026, at 2:37 in the morning local time, the North Sulawesi subduction zone ruptured at a depth of 17 kilometers with a magnitude of 6.7. The rupture propagated at 3 kilometers per second across a fault segment that had last released major stress in 2018, 8 years of accumulated strain released in less than 60 seconds. In Manado, a coastal city of 430,000 people, the shaking reached modified Mercalli intensity 8, the level at which unreinforced concrete walls crack, chimneys collapse, and poorly connected roof-to-wall joints shear through. 23,000 residents spent the following 3 nights sleeping in city parks and schoolyards rather than return to buildings they no longer trusted. To put magnitude 6.7 in context, that is 35 times the energy released by the Northridge, California earthquake of 1994, a quake that caused $25 billion in damage to one of the most earthquake-prepared cities on Earth. Sulawesi is not Northridge. 48 hours later, the Caribbean lit up. On June 19th, at 11:42 in the morning, the seafloor beneath the Gulf of Paria broke. Magnitude 5.8 at a depth of 12 kilometers. Shallow earthquakes are the dangerous ones. The shallower the rupture, the less crustal rock there is to absorb and scatter the seismic energy between the break and the surface. At 12 kilometers, a 5.8 delivers ground shaking equivalent to a much larger deep earthquake. 11 seconds. 11 seconds of sustained shaking doesn't sound like a long time until you are standing inside a building from the 1930s watching the walls move. The event was felt across Trinidad, Tobago, Venezuela, and northeastern Grenada, more than 400 kilometers of populated coastline, registering the same seismic pulse within the same 90 seconds. That changed fast than California. Between June 20th and June 22nd, a swarm of 15 earthquakes struck the Parkfield segment of the San Andreas Fault, the largest reaching magnitude 4.6. The Parkfield segment is the 40-kilometer stretch of central California that seismologists have called the creeping section for 60 years, because unlike most of the San Andreas, it moves almost continuously at 30 millimeters per year rather than locking and releasing in sudden ruptures. That steady behavior is exactly why Parkfield became one of the most densely instrumented fault zones on Earth. Scientists can detect changes in the fault's character that would be invisible elsewhere. The swarm alone is not the story. The story is where Parkfield sits. To its south, the southern San Andreas has not produced a full-length rupture since 1857. 169 years of accumulated stress, with the Pacific Plate now displaced approximately 7.8 meters relative to the North American Plate since that last full release. To its north, the Hayward Fault last ruptured in 1868. A Hayward full rupture today, according to USGS modeling, would produce 800 direct deaths, 18,000 injuries, and $82 billion in economic damage to the East Bay alone. The Parkfield swarm is not either of those events, but it sits between them like a pin in the center of a map. Zoom further out, and the picture expands. Africa's East African Rift, the 2,800-kilometer suture where the African continent is slowly tearing itself apart at 6 to 7 millimeters per year, shifted beneath Lake Tanganyika on June 18th. Japan's instrumented coast registered a magnitude 6.1 offshore Tohoku, 70 kilometers from the coast, devastated by the 2011 megathrust and tsunami that killed nearly 20,000 people. Turkey, still processing the psychological and structural aftermath of the February 2023 event that killed 51,000 people, recorded 12 measurable aftershocks in a week as the East Anatolian Fault continues to redistribute stress. 6 continents, 7 significant events, 14 days. Now here is the question you are already asking. Is this connected? Is something larger happening underneath all of these separate events? This is exactly where the science needs to slow down and speak clearly, because the answer matters, and it is more nuanced than the headlines suggest. The straightforward answer is no. These earthquakes did not trigger each other in any chain reaction sense. Earth's crust is not one rigid shell. It is broken into approximately 15 major tectonic plates and a dozen smaller microplates, each moving on its own trajectory, driven by the convection currents in the partially molten mantle below. Indonesia's North Sulawesi subduction zone, the Caribbean strike-slip boundary beneath Trinidad, and the California San Andreas system are not mechanically coupled. A rupture in one does not load stress onto the others in any meaningful, direct way across distances of 8,000 to 12,000 kilometers. Scientists generally do not conclude that geographically separated earthquakes of different sizes on different fault systems in different tectonic settings represent a unified phenomenon. The USGS is explicit on this point. There is currently no scientific evidence that the global clustering of the past 2 weeks signals an imminent large rupture in any specific location. But here's the part that changes the conversation. What these events do share is not a mechanical connection. They share a global baseline that most people have never actually absorbed. Earth averages 100 to 150 earthquakes of magnitude 5.5 or larger every single year, roughly 3 per week, every week without pause, across every plate boundary on the planet. In a 14-day window, 7 significant events is not an outlier. It is a Tuesday. What makes this cluster feel different is not the seismology, it is the geography. Several of these events struck within or adjacent to densely populated zones carrying documented, overdue, scientifically measured seismic risk. To understand why each region is seismically active, you have to look at what each fault system actually is. Indonesia sits at the most seismically complex convergence point on Earth. The triple junction where the Australian plate, the Eurasian plate, and the Pacific plate all interact within a zone roughly the size of Western Europe. The collision and subduction of these plates generates approximately 40% of the world's total released seismic energy. The country has produced 4 of the 25 strongest earthquakes ever instrumentally recorded. The North Sulawesi subduction zone that broke last week is just one of dozens of active fault systems operating simultaneously across the archipelago. The Caribbean plate is different in character, but not in consequence. It is a small, independent plate squeezed between the North American plate to its north and the South American plate to its south, with its eastern edge diving beneath the Lesser Antilles and its northern and southern boundaries grinding laterally past its neighbors in strike-slip motion. The boundary beneath Trinidad is a right lateral strike-slip fault. The plates are moving horizontally past each other, not diving underneath. That lateral grinding produces frequent shallow earthquakes in a region where building codes and seismic awareness have historically lagged far behind the risk. California's San Andreas is also strike-slip, but it carries a different weight. The Pacific plate is moving northwest relative to the North American plate at 46 millimeters per year, roughly the growth rate of a human fingernail. The fault does not release this motion smoothly. It locks, it accumulates stress, and then, eventually, in seconds, it releases decades of built pressure in a single catastrophic rupture. The southern San Andreas has not done that in 169 years. What all three of these systems share is not a synchronized seismic clock. What they share is the condition all active fault systems always inhabit: constant accumulation of stress between irregular, unpredictable, inevitable releases. The planet is not sending a new signal. It is sending the same signal it has always been sending. Most of us just do not hear it between the earthquakes. Now let us talk about what the difference between identical earthquakes actually looks like in human terms. In February 2011, Christchurch, New Zealand experienced a magnitude 6.3 earthquake, so smaller than the Sulawesi event by a factor of nearly 3 in energy terms. 185 people died. In the same year, the 2010 Haiti earthquake struck at magnitude 7.0, larger than Christchurch. An estimated 230,000 people died. The size of the earthquake was not the primary variable. The buildings were. Indonesia knows this lesson and is still learning how to apply it at scale. The 2018 Palu earthquake and tsunami killed more than 4,000 people, a disaster that exposed critical gaps in both building standards and evacuation infrastructure. Since then, Indonesia's BNPB, the National Disaster Management Authority, has expanded early warning coverage along most of the Sulawesi coast, improved coordination with the Indonesian Meteorology, Climatology, and Geophysics Agency, and pushed seismic retrofitting programs in provincial capitals. But the gap between receiving a warning and having a safe, reachable destination remains enormous in coastal communities where evacuation routes share narrow roads with the same buildings likely to partially collapse in the first 30 seconds. The Caribbean carries a different version of the same problem. Trinidad and Tobago operates one of the better regional earthquake monitoring networks, with sensors capable of detecting events as small as magnitude 1.5 across the island chain. The warning system exists. The building stock is the vulnerability. Significant portions of Port of Spain's commercial and residential inventory date to the British colonial era, construction methods that were never designed for lateral seismic forces. A 5.8 at 12 kilometers depth is survivable. A 6.5 at the same shallow depth above the right soil conditions could be catastrophic. And California, for all its investment, is not immune to the arithmetic. California's Shake Alert system now delivers 2 to 30 seconds of advance warning to millions of residents before ground shaking arrives. The state has spent decades and billions of dollars on bridge retrofits, soft-story apartment requirements, and hospital seismic standards. By almost every measure, it is the most prepared large population center in the Western Hemisphere for exactly the event it knows is coming. And yet, the USGS shakeout scenario, the best modeled estimate of a full southern San Andreas rupture, still projects approximately 1,800 direct deaths and more than $200 billion in damage to the Los Angeles basin. Best case, fully prepared California, after decades of investment. That number is not a failure of preparation. It is the baseline cost of living above a fault that has not fully released in 169 years. Preparation reduces the toll. It does not eliminate it. These are not just geological events. They are human experiences being deferred. So what are scientists actually watching right now beyond the 7 events that made this past week's headlines? The signal that USGS geophysicists are monitoring most carefully in the western United States is not the Parkfield swarm on the San Andreas, it is the Hayward Fault. The Haywired scenario, published jointly by USGS and a consortium of state and local agencies, models not just the earthquake itself, but the cascade of consequences. The failure of unreinforced masonry buildings concentrated in Oakland's older neighborhoods, the rupture of water mains that would compromise firefighting response for up to 90 days, the disruption of the Bay Area rapid transit system serving 400,000 daily riders, and the isolation of communities on the East Bay Hills where road failures would block evacuation for weeks. The Hayward last ruptured in 1868, 158 years ago. Its average recurrence interval, based on paleoseismic trench excavations, is estimated at 140 to 150 years. The fault is, by that measure, already past due. In the Caribbean, the Puerto Rico Trench deserves more attention than it typically receives. It is the deepest point in the Atlantic Ocean at 8,376 meters, sitting directly above a subduction boundary where the North American plate is diving beneath the Caribbean plate at about 2 centimeters per year. A 1946 earthquake in this system generated a local tsunami that killed 1,800 people along the Dominican Republic coast. USGS modeling suggests a full-scale Puerto Rico trench rupture could generate a magnitude 8.5 or larger, with tsunami arrival times of under 30 minutes for Puerto Rico's northern coast. NOAA's Caribbean Tsunami Detection Network exists. It has been underfunded for years. FEMA's seismic risk map for Puerto Rico places the entire island in one of the highest hazard zones in the United States. The last major public conversation about Puerto Rico's seismic risk was driven by the January 2020 magnitude 6.4, which caused 6 deaths and displaced thousands. That conversation faded within months. Keep an eye on Indonesia's Mentawai Gap, too. The Mentawai Gap is a 300-kilometer segment of the Sunda megathrust, the same subduction zone responsible for the 2004 Indian Ocean earthquake and tsunami that has not fully ruptured since 1797. GPS monitoring shows the segment is currently locked and accumulating strain at approximately 3 centimeters per year. Scientists estimate it could generate a magnitude 8.5 or larger when it breaks. The city of Padang, population 1 million, sits on the coast directly in line with the gap. Tsunami travel time from the Mentawai Gap to the Padang waterfront, approximately 30 minutes. The city has been building vertical evacuation towers for years. There are not enough of them. What scientists monitor most carefully is not the dramatic global cluster that makes a 14-day news cycle. It is the fault behavior in the gaps, the locked segments, the overdue recurrence windows, the quietly accumulating stress that has no recent event to call attention to it. So let us come back to the question this video started with: what is the planet trying to tell us? The honest answer from the scientific record is this: nothing new. There is currently no scientific evidence that these 7 events represent a coordinated global increase in tectonic activity. The planet has not entered a new seismic era. Scientists cannot predict when or where the next significant earthquake will strike. The USGS, the Geological Survey of Indonesia, the Seismic Research Center in Trinidad, and the Japan Meteorological Agency all agree on one thing. Earthquake occurrence remains fundamentally unpredictable in timing, even when the locations of risk are well understood. The Cascadia subduction zone is not waking up on schedule. The southern San Andreas is not about to announce itself. The Mentawai Gap will break on its own timeline, not ours. But here is what is real. The most dangerous earthquake risk you face today is probably not the dramatic global cluster you watched on the news this week. It is the fault system running quietly beneath your own city, the one that has not made news in decades or a century or more, and for exactly that reason feels like it does not exist. The Hayward Fault, the Puerto Rico Trench, the New Madrid seismic zone, the Wasatch Front running directly beneath Salt Lake City, the Ramapo Fault beneath the New York metropolitan area. These are not science fiction. They are documented, measured, and in several cases overdue. What the planet is trying to tell you is not that the end is near. It is that the window for preparation is always shorter than it feels. Drop a comment below. Have you ever personally experienced a real earthquake, one that actually moved the ground beneath you? Tell me where you were and what it felt like. I read every single one. If this video helped you understand what is actually happening out there, hit the thumbs up. We are going for 5,000 likes on this one, so the algorithm shows it to the people who need to see it most. Subscribe if you want to be the first to know every time something significant happens. Let us go. See you in the next one.